Hello everyone. Thank you for giving me the opportunity to participate in this conference. Let me introduce myself. My name is Sara Gutiérrez. I'm a researcher at the University of Burgos, and I'm part of Building Engineering Research Group. This is a multidisciplinary group comprised of industrial engineers, architects, and chemists. We have over 14 years experience researching the reuse of different types of waste and its recovery in the design of sustainable construction materials. Now, I'm going to give you a summary of the Liverpool Use Project. Liverpool Use Project is a European project and addresses the problem of polyurethane waste management through the use of innovative techniques of reduction and reuse, integrating them into a new gypsum PU ceiling tile. This project began in September 2018 and finished at the end of last year. The project was coordinated by the University of Burgos in Spain, in partnership with Texa, which is a Spanish construction company, and Jesse Forma, which is a ceiling tile manufacturer from Spain, in collaboration with the University of Coventry in UK and PAP, a Spanish manufacturer of polyurethane panels. Liverpool Use expresses the idea of circular economy. This picture shows the phases from the initial waste generation to the end of its life. First, PU waste is generated in a factory of PU panels, and then it's used in the production of new ceiling tiles, which are then used in a building. If this building is demolished at the end of its life, PU waste can be recovered and the process can start again. The main aim of this project is to develop a new building material. So, and now the objectives of this project are to maximize the reuse of PU waste, reduce the extraction of natural resources of the implementation of the new technology can substitute gypsum by PU waste, reduce the consumption of energy and water compared to the current manufacturing processes. Another one of the objectives is to transfer and replicate this project to other EU countries. And finally, the last one is to include civil society and local actors in order to promote sustainability in the construction sector. Okay. And how we can achieve these objectives? By designing a new environmentally friendly ceiling tile, as you can see from this picture. Okay. Moving on to the project's work plan. It begins with the recovery of waste from the generating industry, which is PAP in Spain. The waste is transported to the Jesse Forma manufacturing plant in order to manufacture new ceiling tiles using the technology developed by the University of Burgos. This material has been used in 3 different sites in Coventry and Spain, where we have been monitoring the energy efficiency, humidity, and temperature parameters in order to analyze the comfort of the interior spaces of the buildings. Okay. A key phase of the project has been the design of mixtures substituting different amounts of gypsum with PU waste and optimizing and testing the mixture in order to discover the technical qualities. All tests were carried out at the University of Burgos laboratory and at the manufacturing plant, so that the laboratory and manufacturer work together or jointly. Okay. In this picture, you can see the Gesiforma plant on its arrival, the manufacturing plant. The waste is placed into an industrial reader. The powder obtained is mixed with gypsum and other components in order to produce a new ceiling tile. When comparing the new tile with the standard version, the new material is 32% lighter. Its thermal conductivity level is almost 26% lower, and the reaction to fire classification is A1 according to Eurocode, which is the highest. Okay. And now I'm going to talk about the life cycle assessment. During the project, a life cycle assessment of the standard ceiling tile and the new tile was carried out, and the results of the assessment was compared. The process was not carried out from cradle to cradle due to the fact that the manufacturer has not recovered the PU and the gypsum waste yet. Okay, so the system of this life cycle assessment is from the cradle to the grave. Okay. The regulation followed was the European Environmental Management regarding life cycle assessment. The assessment was carried out at the Gesiforma manufacturing plant from 2018 to 2020. We used 1 square meter as the functional unit in the system. And here you can see all the other materials and the amounts per square meter additive. Okay. 1 square meter of our new ceiling tile has 0.35 kilograms of polyurethane waste, no? And 4 kilograms, 0.23 of gypsum. No? In comparison, you can see the comparison with the standard square here. Okay. Now you can see the system, the product system. No? The product system is comprised of the following unit processes: raw material extraction, raw material transportation to the manufacturer, ceiling tile manufacturer, which is here, transportation of the finished tile for installation, transport, installation, period of use in a building, here, and finally, the tile disposal. Okay. Each unit process has its own product flow and its own inputs and outputs. The inputs are the raw materials and the energy, and the outputs are waste and the emissions, which are given off from each unit process, of course. Okay. Here you can see all the complete system definition. No? The first unit process is the provision of raw materials here. This process includes the environmental impact and the energy used related with the extraction and the processing of raw materials. The next one is about the transportation of raw materials, the transportation of these materials from the supplier's processing plant to Gesiforma facility. has been analyzed. Fuel consumption and emissions have been included. In this case, transportation took place by means of road. And here, in gray, you can see the manufacturing process at Gesiforma. This process includes unloading of the raw materials, shredding of polyurethane waste, and incorporating it in the product. Mixing raw materials, placing mixture into models, and drying, finishing, packaging, storage, and loading goods for transport. Okay. The process of transport analyzes this process of the tiles to the location where they are used. Unloading of tiles. This process analyzes this process at the client's facility or at the building site where they will be used. The task of installing the tiles in buildings is also analyzed. Then you can see the use and disposal. Disposal, during this stage, the removal of the gypsum tiles from buildings and the transportation of the waste to landfill is analyzed. Okay. Next, this table shows the results obtained from the LCA, the life cycle analysis, for each impact category. The percentages show the comparison between both models. Okay, in the case of global warming impact category, the PU gypsum ceiling tile has a significant reduction in CO2 emissions compared to the standard model. This difference is mainly due to reasons: the lower consumption of natural gas necessary for drying, due to the new product drying more quickly. The other reason is because of the lower consumption of fuel for transport. This is down to the lighter weight of the new ceiling tile. In the case of acidification of the soil and water, the PU gypsum ceiling tiles indicates a 9.52% reduction of emissions, equivalent to kilogram sulfur dioxide per square meter. And in the case of eutrophication impact, the PU gypsum ceiling tiles indicates 8.95% reduction of emissions, equivalent kilogram phosphoric acid per square meter. In both cases, compared with the standard gypsum ceiling tile. This decrease is based on the low consumption of natural gas necessary for the drying of a new product, as well as the lower consumption of fuel for transport. Under the impact category, photochemical ozone formation, the new ceiling tile shows an increase in acetylene in 90, more or less 19% compared with the standard gypsum ceiling tile. Although the difference in percentage seems greater, the difference is only 0.00002 kilogram of acetylene per square meter. So the difference is very low. Okay. Okay. Under the next impact, is depletion of abiotic resources. There is I'm not sure if I can. 30.18 reduction of fossil fuels megajoule per square meters. Okay. The next impact category is net use of fresh water. The new product has a 25.22% reduction of fresh water in liters per square meter compared with the standard gypsum tile. This is due to the lower water content required in the new tile. This impact category that has the greatest difference between both ceiling tiles is non-hazardous waste eliminated in landfill. There is a 31.18% reduction of waste in the PU gypsum tile compared to the standard tile. This difference is due to those two aspects. First, by reusing polyurethane waste, avoiding its disposal. Secondly, the decreased amount of gypsum waste generated due to the new tile having a lower mass than the standard gypsum tile. So, the final, due to the positive results of the LCAA and the beneficial technical specifications, the new product has obtained the Ecolab label. Please have a look at this slide, which shows the Ecolabel, the packaging, and the link where you can, sorry, it's not very clear. You can find the complete document, okay, in the website of the project. Okay, and now to conclude. 75 tons of polyurethane foam waste could be recovered in the first few years of its launch. A new product has been developed with a lower consumption of raw materials, 25% saving in water and 31 more or less percent reduction in gypsum. The life cycle assessment of the Liverpool Use product compared to the standard product shows significant improvements in CO2 reduction, and we can find 30% and 14% lower energy consumption in its manufacturing processes. The new product has CE label, eco label, and the packaging is already been designed. So Gesiforma has provided all of this information along with sample to its distributors. And now, thank you very much for your attention. If you have any questions, I can ask you by email, or I invite you to have a look at our website, livereproduce.com. Thank you very much.